Hi everyone, welcome back to my YouTube channel. So this is the third video of the rectifier series. In last two videos, I explained about the construction and working of the half-wave rectifier, and also we discussed the two important parameters, that is average value and the RMS value. So in today's session, we learning about the one of the important factors, that is the ripple factor. So first thing, what is the ripple factor and what is the importance of finding the ripple factor in the half wave rectifiers? First main thing, the ripple factor. What is mean by ripple factor? So let me know, do comment in the comment section. So now ripple factor is, so when we are converting the AC to DC by using the rectifiers, so these rectifiers cannot convert the AC to pure DC. Means it will conduct only from the AC to pulsating DC. Pulsating DC means it presents some AC components in that converted DC. So that AC components is called ripple content. So to find out how much amount of ripple content presenting in that pulsating DC, to find out that we have to learn about the ripple factor. So to find out the ripple factor, we have a formula. So based upon that formula, we can going to find out the ripple factor. So now I think you have got the idea to find out the ripple factor. What is the importance of ripple factor? So this is you should to find out the how much amount of ripple content presenting in the half wave rectifier. So now by using the formula, we can find out the ripple factor. So the formula is ripple factor is equal to RMS value of the AC component to DC value. So this is the formula. So by using this formula, we can find out the ripple factor of the half wave rectifier. So from this formula, what is IAC RMS by DC value, I DC. So this is the formula to find out the RMS value. So from this we don't know the IAC RMS. So to find out this, and we know that I square RMS is equal to I square DC plus I square AC into RMS. Okay, see, we have to find out this value, right? So bring this I square DC this side. So what we get, I square AC RMS is equal to I square RMS minus I square DC. So now IAC RMS is equal to, bring the square this side. Now what we get, this square will become root. So root of I square RMS minus I square DC. See, now we know the formula for IAC RMS. So now substitute this formula in this equation. So now what we get? So the formula is ripple factor is equal to IAC RMS by IDC. Now we know the formula for the IAC RMS. So what is that? Root of I square RMS minus I square DC and IDC. So now what we have to do is divide the numerator and denominator with I square DC. Divide. So now root of I square RMS by I square DC minus I square DC by I square DC. See here, I square DC and I square DC will get cancelled. Now what remains? Root of I square RMS by I square DC. DC minus 1. So as we know, in the previous video, I explained about the RMS value and average value. So this average value is also called as the DC value. So what is the value for RMS? RMS value is IM by 2. And average value is IM by pi. Now substitute these two formulas in this equation. So now what we get? So root of I square RMS by I square DC minus 1. So what is the I RMS? So I RMS is Im by 2. So root of Im by 2, here we have square value, right? So square by IDC value is Im by pi. Im by pi, here we have square. So whole square minus 1. So now root of Im square, 2 square is 4 into, so it will come up means I square by Im square minus 1. See here Im square and Im square will get cancelled, and what it remains? Root of pi square by 4 minus 1. So as we know the value for the pi, that is 3.14. So pi square means 9.86 something. So by the calculator we can find out the I square by 4 minus 1, that is approximately 1.21. So this is the ripple content which is presenting in the pulsating DC. So this is about the ripple factor. So, and I am repeating it once again, just listen carefully. So first main thing is ripple factor. This ripple factor which is used to, when we are converting from the AC to DC, there are some ripple content presenting in the converted DC. So to find out how much amount of ripple content presenting in that converted DC, by using this formula we can going to find out. So the main formula is the RMS value of the AC component by the DC value. So but we don't know the RMS value of the AC component. But we know the formula, that is I square RMS is equal to I square DC plus I square AC into RMS. See now we have to find out the IAC RMS, right? Now bring this I square DC this side. What we get? I square minus I square DC. So bring this square this side. So IAC RMS is equal to root of I square RMS minus I square DC. So now we know the value for IAC RMS. So substitute that equation in the main equation. So what now? Ripple factor is equal to IAC RMS by DC. We know the formula, that is root of I square RMS minus I square DC by DC. Now what we have to do? So we have to divide numerator and denominator by I square DC. So now what we get? Root of I square RMS by I square DC minus I square DC by I square DC. Here it will get cancelled and remain 1. So now root of I square RMS by I square DC minus 1. So as we know the formulas for the IRMS and the IDC. So substitute that formulas here. So what we get? Im by 2 whole square by Im by pi whole square. So by substituting all this we get the ripple factor, that is 1.21. So this is the final answer for the ripple factor. So this is about the ripple factor. In next video we will see the efficiency of the half wave rectifier. So that's it for today's video. See you in the next video, and don't forget to subscribe my YouTube channel, like and share this video with your friends. Thank you for watching and keep supporting guys.